Plus 1, 22. Wait, are you going on the Yeah. Okay, well. Alright, settle down, guys. We're beginning. 22 was just sketching.
Oh, 5.
Can you go with 33?
Wait, yeah, what's 22? Someone said 22.
Can you go with 33?
What does 22 say?
Oh,
Who asked for 22? What does it say?
F of x equals
Hey, quiet. F of x equals
4 minus x squared if negative 2 is less than or equal to x less than 0. Also, 2x minus 1, so f of x equals 2. If 0 is less than or equal to x less than or equal to 2.
Okay, so it's a piecewise, that's it?
Find the absolute relative maximum.
Okay, so we want to find all extrema. How do you do that? You could sketch it, that's one way to do it. That's
no, it's not.
Put a lot of intuition into it. What?
It tells you to sketch.
Oh, so it says by sketching, okay. So what does 4 minus x squared look like? So we know it's just an upside down parabola that goes through -2 and +2. But we don't want the whole thing, we only want the part from -2 to 0, which is an open hole. You ignore the rest. And now we go to 2x plus 1. Now when x is 0, this gives you -1. So this guy starts here. And when x is 2, this gives you 3. So this went up to 4, 3 is just below it. And so this is here. What's this intercept here? 1/2. Right? When x equals 1/2, that is equal to 0. Okay, so that's our picture. What's the absolute maximum?
There's no absolute maximum.
Absolute max? None. Right? There's no point that's bigger than every other point. The guy who was a candidate for absolute maximum is this guy, but you never actually attain him. So there's no absolute maximum. Absolute minimum? The lowest value that is attained is here, which happens at f of 0 minus 1. Any relative maximum? Nope. None. Relative minimum? Any point where he's lower than all other points to both the left and the right? Sorry? Not by our definition.
Wait, how? Isn't the one at 2, 3, isn't that a relative max?
This?
Yes.
No, there's no one to the right. Remember, our definition says you have to look at guys to the left and right. You have to look at all guys closely, but there's no one on this side. So. Same reason this one is not a relative minimum. He's smaller than all guys on his right, but the guys on his left, they're all bigger than him.
So can there be a relative max if there's no absolute max?
So, what?
Can there be a relative max if there's no absolute max? So let's say there's another, I know,
It's possible to have a relative max. Wait, this one is a relative minimum.
Yeah, that's what I'm saying.
About 0 equals -1. Right? Because this point, he's smaller than everyone on his right. He's also smaller than everyone on his left.
Yeah.
Right.
We go with 33.
But yes, it's possible to have a relative max, but no absolute max. So, for example, I could just tweak this function a little bit and obtain something like that. What if it was something like this? Right? This would be a relative max, but it's not an absolute max because there are points bigger than it. The top of the hill, in my example. could make a graph like this, and then something that's just a hill here. So this guy would be a relative max, even though no absolute max.
Because the curve goes up, but it never touches the highest point.
Right, it never attains a point. There's no y value that's higher than 1. Yeah?
After 0, negative 1, it could be relative and the absolute both, right?
Yeah, you can't have something that's both. Yes, that's completely fine. Okay, other questions?
5.
I'm gonna ask for 33 first. What is 30?
So, f of beta equals 2 cosine beta plus sine beta squared.
Sine squared
Yeah,
theta?
yeah. And it's gonna find a critical number.
Okay, find critical numbers.
Yeah.
So this is all the theta values where the derivative is either 0 or undefined, right? So first you find f prime of theta, which is going to be what?
Negative 2 sine beta plus 2 sine beta times cosine beta.
Right? This is always defined because sine and cosine are always defined. They're continuous everywhere. So check f prime equals 0 for critical points. So this means that minus 2 sine theta plus 2 sine theta cosine theta equals 0. How do we solve that? Factor 2 sine theta is a common factor, so I can take out minus 2 sine theta. This would leave me with 1 minus cosine theta. This means sine theta equals 0. Were we given a limit for these things or no?
No.
So which means theta is just equal to n pi for every integer n.
Yeah, I don't know where the n came from.
And cosine theta equals 1, which means theta is equal to 2n pi. N is an integer. And we know those values because we know the graph of sine and cosine. So if you look at the graph of sine, and you want to see everywhere it hits 0, right? You'll hit it at 0, pi, 2 pi, 3 pi, 4 pi. And if you go back, it'll hit it at minus pi, minus 2 pi, minus 3 pi. So every integer times pi, it will hit 0. That's how sine behaves. So I know if it's 0, it has to be an integer multiple of pi. That's when it will hit 0. As for cosine, because I know what the graph of that looks like, it starts here and goes like that. And I know this is at 0, this is at pi over 2, this is at pi. I'm just writing with pi. So I just want to hit all the, this would be at 2 pi, this would be at 0 pi, this would be at minus 2 pi. You realize it's only the even ones. The next time it will hit the max, it's going to be 4 pi. And then I'll do it again at 6 pi, and then 8 pi. So I know it's 2n. Someone said 5. So this is the answer here. Which, by the way, this guy covers all of these guys.
Yeah.
So you can just take this, because that would cover both even and odd.
What about just range and pi?
That would skip some guys, right? That would skip things like pi. You would never be able to write pi in this form.
Wait, how is given?
These are just even numbers, because I'm always doubling.
Yeah.
So this is 0 plus or minus 2 pi plus or minus 4 pi plus or minus 6 pi. It'll skip all the 1s, 3s, 5s, 7s, 9s, which I need to happen in. This one will catch everybody.
Just 1, 2, 3, 4.
Yeah.
So the answer is just this one.
Yeah, because these are included in that. Yeah. Problem 5? Oh, it's a picture one?
Sorry, because I'm not sure about everything, that's why I asked.
A complicated picture too. So here's the 0, here's a 1. So it goes like this. Yes, I'm looking at number 1.
Really?
Yes. So this is at a 1. This would happen at a 2. No, this would happen at the 3. 1, 2. So I get this? 1, 2, 3. 4, where this happens. This occurs again at a 2. Or this goes up to a 5. And then down to 3. Then back to 4. Starts again at 3. Goes back down to 1. And this happens at 1. This happens at 2. 1, 2, 3, 4. This P happens at 4. This happens 5. This happens at 6. And this is an open circle that happens at 7. Okay, use the graph to say the absolute low and local maximums and minimum values of the function. Okay, absolute max, absolute min, local max, local min. Okay, I think that's it. So how would we do this?
So the highest point is at 4 and 5, right?
5. So that is f of 4, which is 5. That's the highest value our function attains.
Even though there's no point, that's fine.
Yeah, there is a point. The graph is continuous and passes through that point. Yeah.
There was no min.
Absolute min, any guy that's smaller than everyone else? No, because this would be the only candidate, but we never attain it. So there's none here.
Is that because it's open or because there's no?
Because it's open. Yes, because it's open. Meaning you never actually hit 1, but you keep decreasing towards it. So 1 would have been the absolute min if you attained
Even
it.
if there's no line?
Even if there's no line, yes. Because there's a gap. What are the local maximums?
5.
This is the local maximum here. F of 4 equals 5. Any other ones?
6.
Where? F of 6 equals 4, because this is filled in here. That's the local maximum.
Okay, so how do you know, what's it called? How do you know where the midpoint is, where the middle is, so you know what is higher and what's lower?
Well, you look at the grid. They drew a grid for you. So I know this happens when I'm at 6. And then I look at this point and notice that locally, if I look a little to his left and a little to his right, he's the highest point, right? Everyone on his left is lower, and everyone on his right is also lower. So he's a relative maximum. And are those all the relative maximums? Yes. What are the relative minimums? One occurs here. This point is lower than everyone else to his left and to his right. So f of 2 equals 2 is a relative minimum. Any other point?
F of 5 is 3.
F of 5 is 3. One thing I do do want you to note here is that note f prime does not exist at this point, right? That's just something you should
So
be
you see
aware of.
that point, f of 1 is 3, does that do anything ever from mathematics?
Yeah.
So if we look at f of 1, we get 3. Now if I look to this point, to a little to the left and a little to the right, what's going on? To the left, everyone is bigger. To the right, everyone is also bigger. So that means it's also a local min. Any other ones? I think that's, yeah.
So there's no discontinuity. Yeah, so that was filled in. Both points count as relative.
Both points could not be filled in because it wouldn't be a function. It would fail the vertical line test. So it wouldn't be a function anymore. So it's a whole different set of circumstances.
What is f of 0?
F of 0 is nothing because there's no one on this left side.
On the web side, they only made us list the y-intercept, basically.
Yeah.
Instead of like putting the f of whatever.
Yeah, in the web assign you just enter 5, comma 4, comma, yeah.
So like, if we just did that, like, if we put just 3, would it count for both positions where 3 occurred? Like for local min, 3 occurred at 2 points. At 6 and at 1.
I don't know how web assign would deal with that. I'd probably put 2, comma 3, comma 3.
So just repeat it then.
I would. If it complains, I'll just do it once. Yeah. But on an exam, I'd expect you to write everything. I want you to know that it's the y value that you're looking at. Right, so in this case, if you just wrote 2, I wouldn't know, does he know it's the y value or does he know it's the x value? Right, I wouldn't be able to tell. But if you're at f of 2 equals 2, I know you know what you're looking for. You could write coordinates as well. That's fine. Yeah, you could have said, 4, comma 5. There's a local absolute max at that point. You could say it that way if you want.
For the absolute mean, you have to look for the some of the points right or left, right? For the absolute mean. Only for relative mean you have to look for points.
Right. Yes.
But for absolute, we just look at the highest point of the.
Yeah, for absolute, you don't care. Even if it's at an endpoint, you don't care. You just look for biggest and smallest. That's absolute. For relative, you want in relation to everyone else in his proximity.
What if there is a curve like this, and then there's a gap, and then just a single dot on the top? So what would be the absolute max? That one, that dot?
If he happens to be higher than everyone else, yes. So you're talking about something like this, where there's a gap and then there's a dot here, and it continues here. In this case, this would be an absolute max, yes. But you could have, it's also a relative, right? But you could have something like this, gap, dot, and then it's no longer an absolute max, because there are points that are higher than this. So this is not an absolute max.
Also, there is no relative.
In this case, there is no absolute max.
Okay, there is no relative mean to it. There is no relative max to it.
There's no relative max either.
Can you do 31?
What is 31? Quickly, because we're running out of homework.
I would say the problem.
This is absolute max and relative max. Yes.
It's f of x equals x to the 4th
Equals what?
x to the 4th
Quiet, I'm trying to hear it.
4th. Wait, what? No, x to the 4th.
To the 4/5.
And then times x minus 4 squared. And then you have to find the maximum, absolute max and absolute min. Right?
On what interval?
Is there an interval?
No, I think you have to find the critical numbers.
What?
Find the critical numbers.
Oh, sorry, yeah.
Oh, you want critical numbers. Okay, how do we find them? First you find the derivative. How do we do that?
4/5 of x squared negative 5 times 2x minus 4.
No.
Oh, sorry.
You have to do the product rule, right? So then you have to plus to the fourth times 2x minus 4. So we can actually simplify this a bit. We can factor out.
Yeah, I don't know. That's the part I'm stuck on. I don't know how you factored out x to the negative 1.
Well, x is a common term. You always factor out the lowest power. Right? X and x. Power here is minus 1 to the power there is 4 over 5. Factor out the lowest power, the negative. X minus 4 is also a common term. The lowest power is 1. So I factor out that. And I write what's left inside. I just have x minus 4 plus, what would I be left with? This would be left with x times. It wouldn't be a 2. I took out a 4/5. So what would I have left here if I factored out a 4/5?
10, 4.
Huh?
10, wait,
That's 8 over
5.
8 over 5.
Right, 5 over 2. Okay, because if I take this times that, I get 2. Alright, so now how do I find the critical numbers? We need f prime equals 0 or f prime undefined. Okay, so let's do the first one. Where is f prime equal to 0?
Everything is 0.
This means x minus 4 equals 0 or x minus 4 plus 5 over 2x equals 0. Right? So this means that x equals 4, that's one critical number. Or what would x equal in this case? 8 over 7?
Probably wrong.
Okay.
How did you do that?
4 zeros.
No, not 8 over 7. Like, how did you break it up like that? Just break it up
You
like
factor
that?
it all. You
I
simplify.
factored it.
Yeah.
So if I set this equal to 0, I just said g factor equal to 0.
So there's 3 factors. So 4 over 5x to 1.
That's 0. That's 0.
That's 0. I understand. Why is it with x minus 4?
Because
She's right.
Because multiplication. No addition. Like,
There are 3 factors in this thing, right? You have this guy, you have that guy, and you have this guy. Is this guy ever 0? No, this is 1 over x to the 5th, right? It says x to the minus 5. It's never 0. So I ignore that. This can be 0, and that can be 0. So I find those.
I really think I can do that. Are you I failed my test.
F prime undefined x equals 0. So that's the last critical function.
Wait, I have a question.
Yes? What?
Yeah, but
Do we understand this?
no. Okay, be quiet, everyone. I don't understand why you took out 4 over 5x to the negative 1/5 away from x minus 4. Why didn't you do x minus 4 and then 5 over 2x by themselves? Like, why didn't you separate that one?
it's like x plus 2 parentheses and then x minus 2 parentheses.
I factor this. So you factor by looking for common terms. So x is a common term, so I know I want to factor out this guy, right? Because it's the lowest power. X minus 4 is also a common term, so I don't want to factor out that guy. I factor out the fraction just because, even if I left it in here, it wouldn't make a difference. And then this is what's left over. Yeah, so I just look for common terms, pull out the lowest power. That's the rule. Factoring out constants is personal preference. And then now I realize I have something with 3 factors. If I set that equal to 0, I have to set each factor equal to 0. This factor is never 0, so I can ignore it, because that's 1 over x to the 5th. 1 is in the numerator is never 0, so the fraction can't be 0. This can be 0 and this can be 0 at these points. To get it undefined, this x has to be 0 because this guy you divide by 0 in that case. So these are the critical numbers. Yes. One more problem, do an actual problem. You said 42, right? Which is? What?
T times radical.
Radical.
4 minus t squared.
F of 1.
F of t.
That's pretty well.
This is question 41.
That's it.
Maximum and minimum between those negative 1 and 2.
You still roll 42.
Absolute maximum.
That's question 41.
That's 41.
Is 42 similar? Like, what is 42?
42 is nowhere close to that. No! Why'd you read the problem?
What is 42?
X over 41 squared.
Huh?
X over x squared.
X over x squared
Minus x.
like that?
Yeah, the interval is 0 to 3.
0 to 3. I guess absolute maximum. Hey, can you guys quiet down?
Absolute maximum.
Okay, so how do we find absolute maximum? There was a whole method to this.
So we find the endpoint values and then we find the critical points.
All right, so let's work on critical points first. So we need to find f prime. Yes?
I don't know if this is like a pattern or just so happened to be a coincidence, but I tried multiple problems and what they did was just, in order to get f prime, you just basically do x parentheses x minus the constant on the bottom, and then just square the bottom.
Yeah, that's probably a coincidence if you see that. It won't always be there. But I'm glad you're trying to look for a 4, which is what it's trying to do. But that actually doesn't pan out. If you do enough examples, you realize that. So f prime in this case would be what? Bottom times derivative of the top minus the top times derivative of the bottom over the bottom squared. So this would be equal to what? It's just be x squared minus x plus 1 minus 2x squared plus so it's just 1 minus x squared. Okay, so that's the derivative. So what are the critical points now? So for critical prime equals 0 or f prime undefined. In this case, this would be 1 minus x equals 0 or 1 plus x equals 0. In this case, you would have x squared minus x plus 1 equals 0. So this tells you x would be 1 or x would be minus 1. How do you get this equal to 0?
Quadratic formula. Try it.
You could use a quadratic formula. So let's see what that means. This would mean x equals minus b plus or minus square root of b squared minus 4. Right? So not real. So it's never undefined because it's never equal to 0. And also here you reject. So you reject these two. Why did I reject this one? So it's not an interval. I only care about numbers between 0 and 3, and this is the only one. So all we have to do now is check these values. We're going to check what is f of 1 from the critical point. We also need to check the endpoints. What is f of 0 and what is f of 3? So f of 1 would be 1 over 1 minus 1 plus 1.
So it's defined at all points, right? It's defined at all points, right?
This particular function, yes. The domain is all real numbers. F of 0 is just 0. F of 3 is going to be 3 over 9 minus 3 plus 1. 3 over 7. This means what is the absolute max? An absolute min. Okay, that's it. No, no more. Pass it over.
I mean about this.
Huh?
How about this?
Oh yeah. What's your question?
Yeah. So this is called the closed interval.
This is called the closed interval method.
But do you have to check if the function is continuous in the interval?
Yes.
You have to do it before, right?
Yeah.
So what did you reject?
I should start doing this. Oh, that's my notes. I don't do homework in pink. No, that's not homework, that's my notes.
Alright, we're going to finish up 3.2. We talked about Rolle's theorem last time. We did an example. Now we're going to get to the mean value theorem. Yeah? Huh? Following is for the word following. Then there exists C in a B such that, here's the important conclusion, f prime of C equal to f of b minus f of a over b minus a. Anyone remembers what this is? Huh? What?
It's in that definition of the derivative. The other way.
That's not the
Oh,
definition.
wait, no. Oh, secant. No, that's
So for what?
yeah. Secant one?
We had a name for it. What is it called?
Different function.
It's from the, it's the part of negative b plus minus.
Average rate of change. Right? By the way, another word for average, as is typically used, is the word mean. And this is why it's called the mean value theorem. It's just saying, under these conditions, there is always a point on the interior of your interval that is equal to the mean rate of change. That's why it's called the mean value theorem. Your instantaneous rate of change will equal to your average rate of change at some point. And it's guaranteed once you have those two conditions being fulfilled. So, give an illustration. And think of any function. Notice in Rolle's theorem, we required that the y values were the same at some point. The mean value theorem doesn't actually care. Right, so here's my a, here's my b. My f of a could be different from my f of b. That actually doesn't matter. Right, so I could do this. And my function could be doing something, whatever it's doing. So now, if you measure the line here, slope of this equals average rate of change, right? What this is saying is you are definitely guaranteed that at some point, in this case, probably like here, the tangent line to that will be parallel to that average rate of change, right? Same slope as average rate of change. Right? There will always be a point in the interior where it's parallel to the secant line. That's basically what it's saying. And there could be several. For example, here would also have that. But it will always be true. So the typical example of something like this would be, again, like traveling somewhere. Basically, if you can cover like 80 miles in an hour, then at some point you had to be going 80 miles an hour. There's no way you would make it otherwise. Right? So that's sort of the thing. Right? Your instantaneous speed has to be equal to the average rate of change at some point. Once you have a continuous function, and it's differentiable at all points in the closed interval. So ROC equals rate of change, yes. So let's do an example.
What is RC? Rate of change.
Rate of change. By the way, MVT is just short for mean value theorem. That's a very typical abbreviation. So I want you to apply the mean value theorem to this function. On this interval.
So A and B are the endpoints.
Yes, A and B are the endpoints of the interval. A is the left endpoint, B is the right endpoint. And computationally, these problems usually aren't difficult, but typically you'd have ugly numbers, so just be prepared for that. It's possible to have nice numbers, but coming up with examples like that is hard. So people usually just don't care, they just whatever, throw down a random example. Because, yeah, or you can Google, but.
Is it minus 3?
Huh?
Is it minus 3?
Minus 3 is not an interval, minus 1 is. Okay, so how do we do this?
Find derivative.
First, check the hypotheses, right? Make sure you can actually apply the mean value theorem. 1, f is continuous everywhere. Right? In particular, on minus 1, 1. And 2, f is differentiable everywhere. In particular, on minus 1, 1, since f is a polynomial. Polynomial are the nice guys, right? They're always differentiable, always continuous.
Yep.
Wait, why do you need to know if it's continuous everywhere, like outside of the interval?
I don't need to know. I need to know that it's continuous on this interval. But knowing it's continuous everywhere means it's also continuous on that interval.
All different.
So now we know the mean value theorem applies. Right, so now I need to find that C.
Yes.
This means there is some C in the interval, open interval minus 1, 1, such that f prime of C is equal to f of 1 minus f of minus 1 over 1 minus minus 1. So what is f prime of C?
3c
Is
squared.
the instantaneous rate of change.
Huh?
Instantaneous rate of change. Right?
This is instantaneous rate of change, that's the average rate of change on the interval, right? So f prime of C, I just differentiate that and plug in C, so it's going to be 3c squared minus 4c
Oh,
minus 4 should be equal to, what's f of 1? F of 1 is what? So that's 9 minus 6, f of 1 is 3. That's your f of 1. Minus, f of minus 1 is what?
9.
Is 9. Everyone agree with that? It's,
Professor, can you take f to f minus 1, then minus f?
you'd have to switch the bottom. If you're switching the top, you have to switch also the bottom. Or just follow the formula, b minus a. Here your a is the minus 1, your b is the plus 1. That's the notation. Under here you have 2. So this would be minus 6 over 2 is minus 3. This means you have 3c squared minus 4c minus 1 equals 0. How do we solve that? Right, does it factor? You can always check that, right? So you try to factor, it would have to look like this, right? But then you try to get that minus 1 and what's going to happen. If you have a minus 1, the signs have to be different, but if you put a minus here and a plus here, that gives you a plus 1 minus 3, doesn't give you a minus 4. And if you put the minus 1 here and the plus here, it gives you minus 1 plus 3. It doesn't give you a minus 4. It doesn't factor, right? So then that means you use quadratic formula. Minus b plus or minus the square root of b squared minus 4 times a times c, so that becomes plus 12 over 2a. That's 4 plus or minus. I can factor 4 out of 16 and 12. When I pull it outside the radical, that becomes 2. This would be 4 plus 3, that's 7 over 6. So this means I have 2/3 plus or minus radical 7 over 3. So what is this roughly? So this is roughly like 2/3 plus or minus. Radical 7 is roughly what? It's 2 point something, right? It'll be between radical 4 and radical 9. So it's somewhere between 2 and 3. 2.64, you can even estimate 2.5 or something like that. So what would this give you? It would either be 4.5, and I'm approximating here, over 3. Or if I take the subtraction, that would be minus 0.5 over 3. So this would be roughly minus 1/6. And this would be roughly what? 4 over 5 is like 9 over 2. What? So it would be roughly 9 over 6, right? Which is bigger than 1. So this one you reject. And this is your guide. So it would be the one with the minus. Because the other one is outside the interval.
Yeah.
C equals 2/3 plus radical 7 over 3 is not in that interval. But that's basically it. So once you verify that it has the conditions, which means it's continuous on the closed interval, differentiable on the open interval, then this will guarantee to be true somewhere in the interval, and you can just set up the equation and you solve for it. That's basically it. Like I said, the numbers are very rarely nice numbers, because no one wants to take the time to figure them out, including myself. What do we do here? Now we're going to show that the mean value theorem will fail for this particular function. prime of c should be equal to f of 27 minus f of minus 8 over 27 minus 8. Yes?
F of negative 8 is imaginary.
No, it's not. You can find negative 8 to the t-shirts. That's not a problem. You're taking an odd root, right? 3 is the root. You can have a negative under an odd root. Yes?
Is it because at some point it's not differentiable?
Right. That's going to be the reason what we're going to say. That's the y, right? Because it is continuous on that interval. That's not a problem. In fact, that function is continuous everywhere.
It's not differentiable.
But differentiability is going to be the problem, and you're going to see why it's not differentiable just now. What does f prime of c look like? 2/3 c to the minus 1/3. See, that makes a problem. That should be equal to f of 27, plug in 27 here, cube root of 27 is 3, square that, you get 9. Plug in minus 8, cube root of minus 8 is minus 2, square that, you get 4. And if you take 27 plus 8, you get what, 35? 5 over 35. Equals 1/7. This means that c to the minus 1/3 should be equal to 3/14. What? This means c would be equal to 14/3 cubed. Now, if you actually know what that number is, that's actually bigger than 27. So this c does not work. The reason, since Rashad is an overachiever and told us already, f is not differentiable. That was a problem. At 0, there's a problem with this function, right? The derivative is undefined because you raise it to a negative power. So the derivative doesn't work everywhere inside, and that's why the mean value theorem can fail in these cases. I thought I drew a picture of what this thing looks like. I'm just going to state 2 more theorems and then I think we'll probably run out of time to do anything else. When we get to antiderivatives, that's when you're really going to see, oh, that's what these theorems are about. But we can state them now.
We'll learn that derivatives, right?
We will learn it, yes. If f prime of x equals 0 for all x in some interval a, b, then f is constant on AB. If your derivative is always 0 for every point in an interval, it means your function is constant on that interval. It's just a horizontal line. Right? That's a very important theorem. And later on, we can phrase this in language that the antiderivative of 0 will be a constant. And you'll see what that means. Another important theorem.
Wait, can you explain the first one again? I didn't get it. Can you explain the first one again?
this means on the interval a, b, your function f, the slope is always 0, right? This is the slope of the tangent. Well, what would that mean? Like at any point in this interval, your tangent line is a horizontal line, right? What it really means is that the whole thing has to be a horizontal line, right? You have to be a constant function. That's the only way that you would end up being 0, the 0 derivative everywhere.
So it just be straight line.
Huh?
So the function
Not a straight horizontal line. It has to be flat. It has to be the same y value all the time. There's no other choice. So another theorem, which is a corollary of this theorem, the following. If you have two different functions that have the same derivative on some interval, then f of x equals g of x plus c. Basically, if you have two functions that have the same derivative, it doesn't mean they're the same. It just means one is different. They differ by a constant. Right? And we're going to use that to our advantage as well. Basically, we're going to realize that the antiderivative of something is some function plus some constant that you're going to have to figure out later. The reverse of a derivative.
Like background?
Yeah, like going backwards, right? So later, so we're gonna have like 2x plus the antiderivative of that. It's gonna be x squared, right?
It's like reverse engineering.
Reversing engineering the derivative. So if you, the notation for this, I don't know, I'm really jumping the gun here, is that symbol. And what you're gonna do is you're gonna go backwards. You know, to get to a 2x, you have to have come from an x squared. But by this theorem, you're gonna always have to add a c to it. Don't worry, that's like chapter 4.
6x.
What?
6x. And the derivative of 6x.
Would be 3x squared.
And also the x
Plus c.
right?
Huh?
X to the power 6.
No, because you get 6x to the fifth. You get 6x.
Oh, yeah.
I don't think I can talk about it.
It's also similar to cover textbook.
We'll stop there.